Good evening, everyone. My name is Ville Sundell, and I'm a Solidity developer. Hey, like in AA meetings. But yeah, I will tell you today quickly how to become a blockchain developer, and I've been doing this as my daily job for a while now, and I started in 2016 summer to do or spring 2016 to develop smart contracts, and let's get started. So, blockchain developer as word is a bit complicated, but because it was already designed and decided to be the title of this presentation, I'm going to quickly show you what kind of blockchain developers there are. So there are these really old-fashioned guys who are doing Bitcoin and Bitcoin code and solutions on top of that. Then there are people who are doing new kinds of blockchains, and then there are smart contract developers, and I'm going to speak more about being a smart contract developer. But as said, the title was decided beforehand, so that's why the title says how to become a blockchain developer. So. Most of you already probably know what is a smart contract, but long story short, smart contract is a piece of code on the blockchain, and a user interacts with the code by transactions, like in Bitcoin. And as we will soon see, Bitcoin is first primitive, a very primitive example of smart contracts, but we will discuss about that soon. And so user is interacting with the code by transactions, and those transactions are sent to miners like in Bitcoin, and miners will mine the transaction, and they will then mine the output of the transaction through the blockchain. And here is the first problem being a blockchain developer. Is right here, the last sentence, trust by immutability. So although the contract can change data and its own memory area, there are still things that, depending on your application, you can't change afterwards because people already agreed on your logic. So this is probably the single thing which makes blockchain development hard, because as we know, writing perfect code is a bit hard, but we will discuss soon about that also. And there are many platforms, or many, that depends how we define many, but there are some platforms which are already running smart contracts or are designed to run smart contracts. And this is just some of them. So first there was Bitcoin, and Bitcoin is mostly about value transfer. So you transfer value from person A to person B. But there is a very small piece of code inside a transaction, but it's not Turing complete. It's not so-called real code. You can't have, for example, loops or things like that in it. Ethereum was the first one to implement those, and Rootstock and Quantum are both using the same virtual machine that Ethereum is using, the EVM. And Rootstock is based on Bitcoin blockchain. It's designed to be implemented as a sidechain, And Quantum is based on the Bitcoin code itself. It's a separate blockchain, but it's based on the Bitcoin core code. And Neo is kind of from scratch a smart contract platform. Quantum and Neo are mostly for Chinese markets or spawned from Chinese markets. So let's focus on this Ethereum thing. And it's officially defined as a secure, decentralized, generalized transaction ledger. And this is directly from the yellow paper. It's not white paper because it's occasionally updated, but it's kind of a white paper. So yellow paper is a document which formally defines the Ethereum blockchain and the virtual machine and so on. And this is by Dr. Gavin Wood, who have been doing like most of the first pieces of Ethereum code. And Ethereum was needed because Bitcoin's smart contract capabilities weren't good enough. It wasn't Turing complete. So Vitalik Buterin and Gavin Wood and others were thinking that they would need a platform which would be like Bitcoin, but with Turing complete logic. So it's working at the moment very much Bitcoin alike. So there is proof of work consensus at the moment. It will be that there are still plans to update it to proof of stake, but at the moment it's proof of work. And every transaction has a sender account and receiver account. A sender account is always human, but receiver can be human or a piece of code, the smart contract. And you can't tell the difference by the address. The address is looking the same for human users and for smart contracts. So you just send transactions from an account to an account, and sometimes the to account is a computer program. And to interact with the network, you need some software to do that. So here are the most common ones, which are still like active. And MetaMask was briefly discussed in the last presentation. So it's a browser plugin. It's very simple to use. So when you get familiar with the Remix tool that we will show soon, the web interface or the web application, you can use MetaMask to send your smart contract to the network. And Geth is the first widely used Ethereum software. And Parity is currently the most popular kind of. And both Geth and Parity are so-called full nodes. So you can the network is consisting of full nodes, like your Geth or Parity. So it will have the whole database, the whole blockchain, and it's a bit heavy, but it's the traditional way to interact with the blockchain. Like you have the blockchain on your computer and you are part of the network. And Mist is somewhere in between. One common way is to use your own Parity or something like that with Mist, if you want. Mist is meant more like interacting with web pages which will interact with the blockchain. So So Mist and MetaMask are doing kind of the same thing, but from different angles. MetaMask is a browser plugin that you can already install to your Chrome or Firefox. And smart contract development is like riding a bike. Except no one teaches you. You have to build your bike yourself. Someone replaces your wheels with squares the next day, and the whole bike is stolen because the value went up from $3 to $300 overnight, and you had a bug in your lock. So it's easy, like riding a bike. So this discusses briefly some of the problems. There are no books, or well, not widely spread ones at least. There are no universities with Ethereum degree. There are no teachers that you can find. You have to use trial and error and mostly error. Then when you finally get your tool set ready, some parts will change. And then you have to upgrade all the other parts of your tool chain also, because someone made some modifications there with a new feature, and then your current compiler doesn't work with that very well, and so on. So it's like that. So welcome to the world of smart contracts. And it's not rocket science, but you can still learn from it. For example, if you look the mistakes that space rockets have been enduring, or you look the flight disaster documentaries, you will quickly gain the mindset how to prepare for something that you can't really think of beforehand. How you prepare to situations that you can't really think of at the moment. So it's a mindset that you will need when you create code which you can't very well update afterwards. So it's the factor that makes the smart contract development challenging. One mistake and you can lose millions. So yeah, the trust by immutability. Of course, there are. This is not truth. This is mainly my personal point of view, that when you make a logic, and that logic should be very well thought, and everyone participating are able to see the logic and agree on it. So you shouldn't make mechanisms to change the logic in the middle of the contract. So this also creates a problem that the code is there forever, and that should be done right for the first time that you are writing the code. So there are all kinds of mechanisms to help that. You can have reviews of the code and audits, but audits are quite expensive. Like if the auditor is looking at your code, that already costs you 10,000. But it's good. Auditing your code is good because you are quite blind for your own code. So it's good, but it's expensive. Like if you have some sort of token which does something, that will cost like 20,000-30,000 to audit in dollars. So for testing, you don't run your code in the mainnet. It's not dangerous if you are just using it yourself, but it's very expensive for you because like in Bitcoin, every transaction costs you some money. And that's why there are test networks. and there have been quite many of them, as you can see. Some of the test networks have been enduring a lot of unnecessary traffic, so-called attacks, if you will. So that's why, ironically, decentralized project has now 2 test networks, which are proof of authority networks, which means that there are a bunch of computers that people trust from different companies, and they are verifying the transactions. So you don't have that kind of proof of work verification there. So these are the names that you will see when you are doing the development, and mainly I'm using Common. And tools. This is not a mistake. Many people who are coming from very established industries say that there are no tools. Well, those are just big complicated tools, but there are tools. But it's true that the industry is 2 years old, so there are not much of tools, and some of them are hard to use. But still, you have your compiler tools. You can use all kinds of debugging techniques and so on. But we will, in our hands-on session, we will see soon how we will use some of the tools. So personally, I'm using this toolset. We are going to use Remix soon, which is a web interface and web application for smart contract development. It's quite simple. It's practical to learn from. I learned with Remix back in 2016, a long time ago. But nowadays, yeah, there is kind of a custom-made setup that I have got used to, and Atom with correct plugins. I think it's very great. So, what is the EVM? You will also see this here and there. So EVM is the virtual machine which will execute your smart contract and the transaction running the code. It's very simple, and it's stack-based. It has only about 90 instructions, which is a very low amount comparing to, for example, processors. And it has 32 bytes word size. And long story short, you give input, you kind of get output. It's not that simple, but yeah, kind of. And on top of this code, this EVM code that you are running, there are all kinds of standards and improvement ideas. And some of them are technical and affect only the wallet and node software that you are running. But some of the proposals are dealing with application binary interface. So this means that you can create contracts which always implement same kind of functions. And that, for example, the token interface, which was just standardized, is one of those. So there is a document telling what kind of functions you should implement and what the function should do and return. And then when you do, for example, token smart contract with that kind of interface, that means that different kind of wallets and web applications can understand your token. And for example, ERC-223 is one interface interface proposal more for tokens, and it's kind of the next token version, which will solve a lot of the smaller problems that we experience with tokens. But those are quite technical, so let's not go into that. So, as we know, EVM is running bytecode, very simple bytecode. So instead of writing that, you need some other way to create a bytecode. So you need a programming language. When Ethereum started, there were LLL, the low-level language, or Lisp-like language is also one of the source of the letters, and then Mutant, which is deprecated already. No one uses that anymore. Then there is Serpent, which is still used, but Solidity took over quite quickly because it looks like Java to me. To many people it looks like JavaScript, but to me it's very Java-alike. And then there is Viper, which is kind of a new Serpent. So then, oh, sorry, I think I'm a part of a teleconference at the moment. Okay, sorry guys, I will hang up. Yeah. So also part of being a smart contract developer is to be always online. But this time I'm not, I'm here now. So, let's try with Remix. It's the web application, so feel free to navigate to remix.ethereum.org, and when you get there, we will see something like not this. Okay, so this is something that we will end up, but we can start building a contract like this. Step by step. So open up with the plus sign there, the button. Open up a new window like that. Bling. And now you are ready to write your first application. Especially the guys nearby, if I'm missing something, please tell me so I can tell more about something which I missed or something like that. So let's start with the pragma. We can copy this start here. First, we will use the pragma to tell the compiler what version we are going to use, because Solidity, when Solidity develops from version to version, you will see that not all of the code compiles. The old code doesn't compile necessarily with the new version of Solidity. So those are not backward compatible. So we will start with pragma Solidity, and then we will define the version which we can set like for, let's say, that 13. So there are more recent versions also, but I don't use the most recent one because there is always possibility that there is some bug that no one really saw, and I trust the versions which are couple of versions, version number smaller, but haven't had any critical bugs in it. So we will use now 0.4.13, And as you can see soon, Solidity is very much like Java. It looks like it would be object-oriented, and well, and syntax is very similar. So instead of classes, we will use like contract, and then let's name this as a vault. So, and then I need brackets, some brackets somewhere. Please help. I can't use computers. Yeah. I did that. Oh, okay. Okay, I need shift. Yeah, I learned Mac here.
Yeah.
Okay, good.
I'm not very good at it with either.
Thank you. So this computer thing is very great. I think this will be popular in a couple of years. So yeah, okay. So now when I have learned to use a computer, let's proceed. Yeah. So reason why we are using Mac is that we can't connect my computer to the projector because it doesn't have HDMI. So that's why we have to use this. So let's see now. This wall thing is very simple that we will construct here. This will take some address and number how many blocks on you it will permit you to cash out your money. So it takes money, it keeps it there for a while, and then when the amount of blocks have passed in the blockchain, it will release the money to you via claim. So we will need to store to the common memory area, your common memory area, your contracts. We need to store an address, and then we need to store the block number that we will release the money after. So and uint here is the it's the full 32 bytes, so it's a very big number, but it's you can use smaller if you want, like this, but problem is that then Solidity will do the boxing and unboxing thing, and there are always room for mistakes, and I don't see anything bad because most of the bytes will be 0 anyway with this kind of big numbers, because network traffic is always compressed anyway, and when you write blockchain to your hard drive, that can be also compressed. So I don't see a problem using full integers here, because it will just affect the execution a bit, but modern computers are so powerful that it doesn't really matter. So just to be on the safe side, I use mainly the whole 32-bit integers. So now we need a constructor for this contract. It's like a class and object if we want to think it that way. So we will name it after the contract. Let's see now the brackets. Whoa! There are brackets. So this is run only once when you are deploying the contract, and here you can see we can, for example, do it like this: owner equals MSG sender. So this means that when you deploy this, you will be marked as an owner. Ethereum smart contract doesn't have an owner concept per se, because that's not really needed. You can implement that if you need in your own code. Like we do it here. We want that the money that we will put into this vault, we want that only the owner can cash that out. That would make kind of sense. So and then we will save the future block number. So we need to do it something like this. Something like that. And now, when the contract is initialized, the block number will be the current block number, and we don't really want that. We want to be +1. So now we can get the money out after one block. And now we would also need a function to cash it out. So we will put something like this function. I think I used claim in that code, so let's name it claim. And now we will send owner transfer, and the money will be like that will be this balance. Okay, so this will transfer this contract's own balance in ethers or ways, because we only deal with ways, the smallest denominator of ether, because EVM doesn't use floating points. EVM just use whole integers, because that's the only sane thing to do when dealing with mission critical code. So now we have a function to claim. Now we would need a function to give money into the vault also, because at the moment, by default, nowadays, in Solidity, functions do not accept ethers or money, so to say, by default. And that's why we need to define that some function must be payable. So we will use now just a default function like this. This will be called if upon a normal transfer, or if you are trying to call a function that doesn't exist, then this default function will be called. And we have to tell them that it's payable, and now it receives ethers. And this is a modifier, and you can do modifiers by yourself, and those are executed before the function itself, in most cases. And there are also a couple of other modifiers which are built in. which deal with visibility. What functions are available to the outside world? And the most used here is public, which means that the function is public and available to the outside world. And by default, functions are public, but this led to like, what was it, 13 million dollars to be lost, because there was a bug in one contract that there were functions which were intended to be only called locally and from the same contract, but because modifiers weren't defined, those were public by default. So that's why we need to nowadays, it's good habit to put their public anyway. And as you can see, it tells warnings about that, but when you define public, it will be happy with that. So now we have a smart contract which upon initialization will save your own address as owner. Then it will define how long it will take in blocks to the money to be released. And then there's a function which lets you claim the money at the moment without any checks. We will implement the checks later. And this will help you to deposit the money. There are ways, there are some ways to deposit, there are ways to deposit money forcefully, but we don't go into that. It's quite technical. So now we can go, and if you have MetaMask installed, you can interact with test networks and the main network. But here on this machine, we don't have we don't have MetaMask installed. So we will just use the built-in JavaScript virtual machine, which is creating kind of a mini blockchain in your own browser. So we can now try this out, and first we see that there are like 5 accounts which all of them have 100 Ether. And this is of course a simulation, otherwise we would be rich. But in this simulation you have these accounts, and there are these balances here. And now we will push create, and hopefully we have a contract here. And let's see, like that, good. I learned this Mac thing, great. So now we see that a bit of gas was used to deploy the contract. It's not 100 Ether anymore. And as an owner, we can now send there, we can do a transaction of 10 Ethers. And we can call the fallback function, the default function, to send the Ether. So we can see now that we only have like 90 Ethers left. And now there was one block more created because of this. So now we can cash out. Or well, we don't have to check yet there, but we would be able to cash out now. So we send a transaction and we call claim, and we have the 10 Ethers back. So this doesn't seem very convincing application, but if you think about it, this deals with or soon will deal with all kinds of conditions and information, and it will decide where the money will go and flow. So so it doesn't look like that, but this is quite cool. It doesn't look like that, but now to achieve our goals of Vault, we now need a check. We need to check if the current block number is more than the locking block number that we define upon initialization. So block number, if that's greater than our block number, then we will do the transfer, else we will revert. And Ethereum transactions are atomic. It either happens or doesn't. And revert means here that nothing is changed. Error happened, and the overall state of the chain is not changed. Well, not quite, but almost. The revert changes something, but never mind that. but so now we have a check. Now if we define here, like, let's say if this virtual machine, JavaScript virtual machine deals with real blocks or decent blocks, this should make, when we create a new contract, hop. Now we have too many of those. Help. Let's see. Where is the remove?
Mutable.
yeah, it is indeed. but from the interface, like when you interact with the network, you know always what's in your own browser's memory and local storage and what is on the network, because, for example, by using MetaMask, it will ask you for every transaction going to the network. So these that we have here are just local, and that's why we could remove, there is an X there somewhere, and we could remove these from the interfaces, so we wouldn't get confused by that. But now we have, anyway, we have a couple of those instances created already. So let's send like 10 ethers back there, like that, and claim. But the claim happened. So this could be the old contract. But yeah, anyway, you probably can do it better than I can do here. But then to create more versatile contracts, you shouldn't use hard-coded values. So we could, upon initialization, we could take some arguments like address, owner, and because we are using the same variable name here as we use in our storage, we use underscore usually to differentiate between those. And then we want the block number, and we also need to use underscore there. So block number, and then we need to use owner here. Oh, okay, we are running out of time. So, but here you have a versatile vault. Yeah, upon every deployment, you can define here, when you create one, you can define an address and the block number that you want to be the money released. So we can copy, for example, our own address, and hopefully paste it here like this. Woohoo! And we put like this, and then some value, and then we create, and we have a contract again. So this way we can recycle the same code, and you should always recycle, because when you create a good code and good logic, you should recycle that, because that's probably already well tested. And quickly, do we have time to